What's up, everybody? This is the other one that is totally optional for you. Potential opportunity to get points back. Notice that it's super similar to that last one. The last one was 16 minus x squared. This one is x squared minus 9. Alright, so if you could hear that annoying person in the background, that is one of my students, terribly, terribly annoying, interrupting my video. But here we go. Function, another semiconic. Again, I was saying it looks super similar, but notice this time the x squared is positive and the other thingy is negative. So the form of this one is square root of x squared minus r squared. And again, if we squared both sides, we could get y squared equals x squared minus 9, which we could then rearrange as x squared minus y squared equals 9. Did a couple steps there, which we could rewrite as x squared over 3 squared minus y squared over 3 squared equals 1, which is the conic form of a hyperbola. Okay, well, what does that mean for us for this square rooty thingy, for this semi-hyperbola? Well, it means this much. That 9 is telling me that the, quote, radius is 3. So I'm going to go to positive 3, and I'm going to go to negative 3. And instead of being a semicircle like that, it is a hyperbola that opens up outwards like that. And that's pretty much it. That's all you need to do. So domain is going to be x values in the set of real numbers such that these x values, I could be like totally snobbish about how I write this, and I'm going to stutter, and then I'm going to totally do it that way. Check this out. Absolute value of x is greater than or equal to 3. Think about what that means. That's a fancy way of saying x is greater than or equal to 3, and or x is less than or equal to negative 3, which is what we wanted. When you have absolute value of x and then a greater than or equal to inequality next to it, you get an or compound inequality. Burp. And then you do one positive one, x greater than or equal to 3, and one negative one, x less than, change the sign, less than negative 3. So there's that. Again, a lot easier in interval notation. X is an element of the interval from negative infinity up to positive 3, including it. But then, wait, lies. Negative 3, there you go. Including that union with this interval starting at 3 and going to positive infinity. So there's that. And let's do the range. Well, range is just going to be all the positive numbers and 0. So y is an element of the set of real numbers such that y is greater than or equal to 0. Interval notation says 0, comma, infinity. Y is in there.